The last video clip demonstrated how we use the light director for first-sided pinning. In that situation, illustrated here, the wires you insert have no electrical contact with the system, and we must rely on wire color or numbers printed on the wire insulation to identify any wire we wish to insert. You may use first-sided pinning to assemble any connector in a harness, as long as the wires can be identified by color or numeric code. This video clip will demonstrate second-sided pinning. In this case, the far end of the wires do have electrical contact with the system. As a result, we can touch a wire with a probe, or with our finger if we're wearing a wrist strap, to identify that wire. In the two-ended cable shown here, the first side has been assembled and connected to a mating connector, which leads to the CableEye tester. The second side awaits assembly. You see here the setup we'll be using during this demonstration. A DB9 connector on the left side has been previously assembled and is shown attached to a mating connector. Bare pins on the right side remain to be inserted into the build connector attached to the light director board. When you touch the probe to any pin selected at random, a signal passing from the probe into the wire enters the CableEye tester, where it's picked up, identified automatically based on the DB9's pin number, and then looked up in a wire list to see where it should be connected. The appropriate LED lamp then flashes in the light director to identify the target, and the cavity number is read aloud. Now I'll show you how the assembly technician uses the CableEye software to build this connector. As with first-sided pinning, we load the cable we wish to build from the database. This file tells us how the cable is wired. The DB9 connector on the left has been previously wired and is attached to the tester. We'll be building the circular connector seen on the right. Let's have a look at the Netlist. This shows the connectors and wire colors. Now I'll start the AutoBuild software.
Press push button to start.
The cable is displayed, and the voice guide asks us to press the black button on the tester, which I will do now.
Enter or scan a serial number for this build.
The serial number is optional and may be typed in, scanned with a barcode scanner, or this step disabled entirely. For this example, I'll just enter 1234.
Insert pin cavity blocks as shown and press push button when done.
All pins which will not be wired take a red plug, so we insert those now. Keep in mind that the graphic images you see on the computer screen serve only as a backup. The entire assembly job takes place while you look at the connector, touch the probe to the bare pins, and listen to the voice. Assembly in this manner takes place very quickly and easily. You need only to look at the screen if you have been interrupted and need to restart your work after a pause. Now I'll pick up any pin and touch it with the probe. I've got the black wire.
Black wire to pin alpha.
I'll press the black button to confirm that the wire has been inserted. This is the brown wire.
Brown wire to pin lima.
Again, the black button to confirm insertion. Let's see what happens if one of the wires comes loose and pops out. I'll probe it again. So I'm going to remove the brown wire and touch it again with the probe.
Pin has become detached. Please reinsert. Brown wire to pin lima.
I'll put the brown wire back into position and press the button again. This is the last wire.
Green wire to pin bravo. Assembly complete. Check all connections and press push button to accept.
At this time, all fibers are flashing under the pins, and we need to review the assembly to ensure that no flashing light is visible. Everything looks good, so I'll press the button to finish.
Assembly complete.
In this demonstration, the black button on the tester was pressed to confirm insertion of a wire. In place of the black button, you may use a foot switch or the system can respond to voice commands like next and back. Alternatively, this confirmation step can be eliminated entirely, if desired, so that every wire you probe is immediately announced by the voice without requiring a secondary action after insertion. In this case, you press the black button only when all wires have been inserted to confirm that pinning is complete. Once both sides of the cable have been assembled, the CableEye tester can also perform an electrical test. You need only to provide a suitable electrical interface for every connector on the cable, and this final step can be completed at the same workstation without disconnecting the cable and moving it to a separate tester. This video clip and the previous one have demonstrated how the light director can be used for first and second-sided pinning to assemble a simple two-ended cable. These methods apply equally well to complex multi-headed cables and wire harnesses. This photo shows a 512-point CableEye system with multiple light boards and electrical mating connectors set up to perform first-sided pinning, second-sided pinning, and finally electrical test. So the entire assembly and test process can be completed at one station by one operator. If HiPot testing is required on the completed cable, the CableEye HVX high-voltage test system can run the light director software and then, with the same fixturing, perform a HiPot test as the last step. The light director offers three major benefits: greatly increased assembly speed, reduced operator fatigue, permitting optimum performance throughout the workday, and lower error rates. All of these benefits result in markedly lower cost to assemble and test complex cables. In general, the cost of fixturing is typically paid back very quickly, with the break-even point reached after assembling as few as 25 cables. CAMI Research is pleased to provide a light director demo system at no charge for 2 weeks, so you can see for yourself how this new technology can benefit your business.